Okay, let's look at Tutorial sheet 3. Where is my Tutorial sheet? I hope to finish this one, so I have to put it first and then move to the other sheet 3. So we did some of these questions, kind of, but we're doing notes then stroke. So now I want to get this. So these questions I build up from question 1, and then we build up question 2. So I hope now I should be able to understand the notes using this Tutorial sheet. Question 1, linearization. Find the linearization of a the root of 4 minus x about x is 0. So what we'll do is we'll name this to be a function. So let f of x be equal to the root of 4 minus x. And so we're able to write it as 4 minus x to the power half. And then to linearize, we need the function f of a plus f prime of a and then x minus a. Meaning that we must find the derivative of f. So what is f prime of x? So f prime of x is going to be half 4 minus x to the power negative half multiplied by negative 1. This is negative 1 over 2 of 4 minus x to the power negative half. This can be written as 1 over 2 negative the root of 4 minus x, like this. So when we do that, our a in this case is 0. So now we find f of 0. So f of 0 is the root of 4 minus 0, which is equal to root 4, which is positive 2. And we also find f prime of 0, which is negative 1 over 2 root 4, which is negative 1 over 2 by 2, which is negative 1 over 4. So we'll say the linearization of this function is going to be f of a, which are found as 2, plus minus 1 over 4, and then x minus 0. So we get 2 minus 1 over 4 x. That is how we get linearization. So this must be a very nice art. Understanding that this x minus a here, this is the change in an interval. If I was dealing with, if this is a, and then I'm having a function that is moving like that. So you're saying you want to check what is happening to the function at this interval here. And if I have so if I have a b here, then it means you get this difference here and then use it to understand the difference here. So if this was f1 and that is f2, here we are saying that when we subtract this b becomes our x. So when you subtract x minus a, which is this interval here, it will give you an understanding of what has happened on the other side via linearization. That is the case of of question 2. So if you look at question 2, question 2 is saying.
Sorry, sir. The previous.
Sir,
Hello.
please repeat on the graph.
So the graph, you have a change based on the x. So if I'm having, or let me explain the graph using question 2.
All right,
So
sir. Thank you.
Okay, so if you are having this a here, and then the value of x, this is x, this is y, represented by f. So the value of x moves, it increases by some number. Then you would say this change here will help us understand what is happening between f1 and f2. Since at A we'll get f1, at B we'll get f2. So it means the increase on the x from A to B impacts the change from f1 to f2. So you can measure the change from f1 to f2 using the change from A to B. Like the case of question 2, by approximately how much does the area of a square increases if its side length increases from 10 centimeter to 10.4 centimeter. So now it's like what we have is something like this. This is 10 centimeter, and then a square has got equal sides. So you have this space, then if you give us the area. How much does this area increase if you increase the side length from 10 to 10.4? So 10.4 will now be dealing with this. So I want to understand how much does the area increase when you increase x from 10 to 10.4. First, you understand what increment is in between. You subtract 10.4 minus 10, you get 0.4. So now, though you can get this using some kind of common sense, say, oh, if I was getting using 10 and then I'm using 10.4, so what could be the difference? But you'll be asked this question after you've been asked to linearize, so meaning that you must use that knowledge. So how do you appreciate it? You say, okay, I know that the area at 10 centimeter, the area at 10 centimeter is equal to L squared, which is 10 squared, which is 100 centimeter squared. Then now we'd say, okay, what would happen if I use the knowledge of approximation? So because the area is L squared, you can form a function f of x to be x squared. And then you get f of a plus f prime of a x minus a. That is f of a, that will be a squared plus f prime of a, we differentiate x squared, we get 2x, and then we put a, and then x minus a. Now this x minus a here is this change that you're talking about here, the change in the x. So then what should be a? A will be the initial. A will be the initial length, that is 10 squared plus 2 x by the change, which is 0.4. So now we are saying we have 100 plus 2 times 10, that is 20. 20 by 1/4. Is it? 20 by 4/10. Yeah, so we get 8. So we're saying plus 8, which is equal to 108. So this 108 is an approximate area that you get. Now, how much does the area of the square increases? What we have found here is the actual area approximated when you increase the length from 10 to 10.4. To get the how much, you say it has to be LX minus the initial FA. So LX is 108 minus the initial, which is 100. So we get 8 centimeters squared. So we're saying, therefore, area increases by 8 centimeters squared. So this, if this was 100, when we increase to 10.4, it increases to 108. Then now you calculate this change in between here. This is not the approximate increase. This is not the approximate increase. What could be the approximate increase? The approximate increase would be, instead of using now a 10, you have increased. So you can use 10.4. So you say L squared is the same thing as 10.4 squared. But this, when you calculate, you get 10.4 per squared. That is 108.16 centimeters squared. The linearization is not the very correct approximation. That's why it understands that you can make an error. And so it brings itself, with itself, a way of calculating that error if it's needed. So you can do the calculations in case you need to know how much you are from making an error, or what is the possibility of made an error. If so, what error have you made? Which interval can you find the error? So I have all those things coming from the analysis and the understanding of knowing that, oh, so it's possible because I've just approximated, I can miss this value, but how far can I miss it? You can be able to know such a thing. So now we go to a specific question that will ask us to know. So let's go to question 3. So what I've done is that on question 1, I've assumed that you guys should be able to write f of x for b at b1 plus x to the power -2, and at x is equal to 1, you can linearize. So you say this guy is f of a, so you put a here, which is 1. So we have 1 plus 1, 2. So we get 1/4 plus, you differentiate this, we'll get -2, and then 2 inside, -3, and then x minus 1. As you can arrange this to 1/4 minus 2/8 x minus 1, which becomes 1/4 minus 1/4 minus 1/4 x minus 1 as a linearization for b. The same thing will happen for c. For c, we have f of x is equal to cos 2x. To cos 2x. So to get f prime of x, which is critical, you get -2 sine 2x. So you use chain rule to differentiate cos 2x. So you get -2 and then sine 2x. Then you substitute what's the angle? The angle is pi over 3. So what is f of pi over 3? That is cos 2 pi over 3. Okay, maybe because of the trig part, we do it nicely. Because of the trig part. So that I can remind you. So on C, 1C, f of x is equal to cos 2x at x is equal to pi over 3. And then first thing, you find f of pi over 3, which is cos 2 pi over 3. Now pi over 3 is 60, so 2 pi over 3 is 120. So we're dealing with cos 120. Where do we find 120? We find 120 in the second quadrant. So this is 120. So you use the reference angle in the second quadrant. So you say 180 minus 120, which is equal to 60. So here we are finding cos 60. So this should be the same as negative cos 60 because cos is negative in the second quadrant. Remember that thing of all students take off. So in the second quadrant, you find cos is negative. That's why I'm saying negative cos 60 because 60 is coming from the first quadrant where cos is positive. So now we have negative. What is cos 60? Cos 60 is half. I don't know if I'm correct. Cos 60. Yeah, cos 60 is half. Good. So that is negative half. So when you get negative half, then we go to the first derivative. We differentiate x. We'll get -2 sine 2x. And then we evaluate at pi over 3. We get -2 sine 2 pi over 3, which is equal to -2 sine. This is again 120. So we are dealing with sine now. Sine is positive in the first and second quadrant. So it's the same thing as dealing with direct sine 60. Now sine 60 is √3 over 2. So here we get -√3. So now we have the linearization f of x is equal to f of a plus f prime of a x minus a. F of a is f of a, we have found -half plus, which is -√3 x minus a, which is pi over 3. So this is what we get in the case of C. Okay. So we're now done with question 1. Then you can now go to question 2. Question 3. In the following, what we want to find? 1. use suitable linearization. Approximate and then two, after you approximate, determine the sign. The sign of the error. 3 of the error and its size. 3, use part 1 and 2 to specify the interval. To specify the interval. And then, okay, to specify the interval you can be sure will contain the value. So you do a root of 50. So the root of 50, the first thing you do here is you assume a function. So because you're dealing with root, so say this means that our function f of x so let f of x be equal to root 50, to root x, I mean, be equal to root x, implying that we are dealing with x to the power half. So this means that x is equal to 50. Then this x is equal to 50 is the direct one in the function, not the a. The a, you look for a closer number to 50 that can give us the whole number when used in the function. If this was a cube root, we would have looked for the closest number to 50 whose cube root we know. Now that this is 50 and we're dealing with root, so we'll look for a closest number to 50 whose square root we know. So the number whose square root we know and is closer to 50 in this case is 49. The root of 49 is 7. So we know the root of 49. So now we look for the first derivative, f prime of x, that is half x negative half. The first derivative, and then, because you're going to got the error here, so you also get the second derivative. So you differentiate again, you get negative 1 over 4 x to the power negative 3 over 2 when you're differentiating there. So the error itself, so first we do the approximation. That will give us f of a plus f prime of a and then x minus a. This will be like saying L of 50. This is going to be f of 49 plus f prime of 49 and then 50 minus 49. So we'll get f of 49, that is root 49, plus f prime, that is 1 over 2 root 49, and then multiplied by 1. This is 7 plus 1 over 2 by 7, which is 7 plus 1 over 14, giving us 7 plus 1 over 14. By getting 7 point, this course we use calculators, so
We are free.
0714 1428 571. That's the number we're getting there. Then now, remember, for the error, you always look for an interval a less than x less than. So a, you pick any dummy variable. Let's say s less than, so a less than s less than x, where x is known, a is known. So in this case, we are using a is 49 less than some dummy variable, which is less than 50, like that. Then you check the second derivative. So our second derivative in this case is here. So our second derivative, f prime prime of x. So now, if we pick s lies from 49 to 50. In between there, we find s. So 49.1, 49.01, 49.003, 49.9. That is, s can take any of those variables. Now, if I take s in -1/4, this can be written as s 3/2. This is the same thing as -1/4 s. This is the same thing as the root of s to the power 3. Now look at this number. S is positive there where it is. And then you get its square root. It will be a positive square root. Then you get the cube of that. It will still be a positive. You multiply by 4. It will be positive. Then you divide into -1. This number, even if we don't know what s is, this number will be less than 0. Because there's nothing that will take away the negative. Now, if f prime prime is less than 0, then it means that on part 2 now, determine the sign of the error. It means that the error is negative. Okay, so the error is less than 0. So the error takes the sign of f prime prime of s in the interval where s belongs. So that is the sign of the error. Is it okay? This is coming from the corollary now. Those corollaries that are complicated. We have that part which was saying if f prime prime is of this sign in this interval, then the error follows the same sign. This is what it meant. Okay, so the Zoom thing, we only have like 3 minutes. I don't know if I can explain well how to determine its size in these 3 minutes. Or I think the best is we allow you to cut and then we join back so that you can get the size freely and then use part 1 and 2 to specify the interval. Let me just save this. So you can be quick to join. No, you don't use no need of, the corollary is just there to guide you on what you should be doing when solving. There's nothing that by corollary what, no. If you get the statements of the corollary when solving, you get, and this is how you should solve. They give you root 50, find the function, you find the function root x. Because it's root and we are dealing with 50, whose root we don't know. So you say, okay, because I'm approximating this root, well, so now what I will do is that I'll pick the closer number to 50, whose root I know. So we pick 49 and then use it in the linearization. You find the number. You see how we use this number. After I find this number, I keep it. Then now I go to the second derivative. The second derivative, I want to use it to find the sign of the error. So if the second derivative on the interval a to x, a is the number that you pick that is closer to 50, whose root you know. X is the actual number. Then now you do f prime prime, the second derivative of that s, where s can be any number from that interval. If the second derivative is positive, then you would say the error is positive. If the second derivative is negative, then the error is negative. Of course, don't expect to find the second derivative 0 in this case. Okay, so we can log out and then we log back so that you can continue this question. So don't forget this page here. Oh, hope we won't have to calculate this value here. Let me see if I can get a shot of it. Okay.